which is properties of solutions. Back in chapter 4, we introduced you to solutions with respect to molarity. We're going to take that way farther because there's a lot more to solutions than that. So we're going to start with our definitions. Solutions are homogeneous mixtures. Remember, homogeneous means that it is uniform throughout. So when you start with a homogeneous mixture, whatever you start with, let's make lemonade. Your first cup should taste the same as the last cup. So you assume it's uniform throughout. The solute is whatever dissolves. So in most cases, it is a solid. For example, again, you're making Kool-Aid or lemonade. You start with a solid and you add water. However, there are all kinds of solutions. There are liquid-liquid solutions. There are solid-liquid solutions. There are solid-solid solutions. So the solute is the solid or the minor component. Most of the time, as I said, what we work with are going to be solids or liquids. Opponent. But if you go to your medicine cabinet and look inside, you may find isopropyl alcohol. You can find 50%, 70%, 91%. That means that if it's less than 50%, that means that the water is the solute, because solvents is whatever does the dissolving. So, for example, if you're again back to the Kool-Aid, you're going to add the solid into the water. The water is definitely there in excess, so it is the major component. And as I said, it's usually the liquid, but if you have a solid solution, brass, then it's not. So just remember, the solute is whatever dissolves, and the solvent is whatever does the dissolving. Solute is minority, solvent is majority. So in the case of the isopropyl alcohol, if you get 91%, that means that out of 100 milliliters, 91 are going to be the isopropyl alcohol, which that means it's the solvent. And water is only 7%, so it's a solute. But hydrogen peroxide is a 3% solution. So the hydrogen peroxide would be the solute and water would be the solvent in that case. So it just varies. As I said, you can have a variety of species. Gas. Air is a prime example of a solution. Gas, liquid, club soda, anything with CO2 and water, that would be uniform throughout until you release the pressure. Liquid, they're using vodka, I'm using Kool-Aid. Solid liquid, seawater is salt and water, Kool-Aid, etc. And solid, brass and other alloys, and a lot of gemstones. Okay, so again, there are two main aspects of solutions. The quantitative are the amounts present of solute, solvent, or a comparison to the amounts. This is more, this is less. Or they're qualitative. And this tells you how or why solutions form. So these are two different aspects. Again, one is qualitative, there are no numbers, and the other one is quantitative, which means we're involving amounts. And so the general rule of thumb is like dissolves like. Now this is no different than anything else. If you go to a party, you tend to hang around with the people you know. Most people, there are a few, who will go hang out with people they don't know, but you tend to want to hang around with people who are similar to you. Okay, so if we go with the like dissolves like idea, and that will be a theme here in solution formation, the more similar the intermolecular forces, the greater the solubility. And remember, we've done the intermolecular forces. We'll review them quickly in just a minute. But the bottom line is the solvents typically are classified as either polar or nonpolar. You've gone back and you've reviewed molecular shape and polarity. Solutes are polar or ionic solutes will dissolve in polar solvents. On the other hand, nonpolar solutes will dissolve in nonpolar solvents. So when we say like dissolves like, we're talking about their intermolecular forces and how they're alike. There are several terms that you need to know. First one is solubility, which is the amount of a solute that will dissolve in a given amount of solvent to yield a saturated solution. Room, so solution is SOLN. Saturated is the maximum amount of solute that will dissolve in a given amount of solvent at a set temperature. At a set temperature. And usually that means that there's solid present. Not always. There might not be much that you can see, but there's going to be solid present. And I'm going to go through these, write down the definitions, and I'm going to come back and talk about them. Unsaturated means that more solute will dissolve. In the solution in the solvent under the conditions. And supersaturated is that the solute concentration is greater than its solubility. Okay, and that is not it is, that is it. Okay, fine. Can't eliminate that. Okay, so what we have here is solubility is the amount of solute that will dissolve in a given amount of solvent to yield a saturated solution. A saturated solution is one in which you can't get any more solute dissolved. You actually have a little solid present or solute present that's not dissolved. Unsaturated means you can add more. Supersaturated means it's greater than its solubility. So I'm going to start with supersaturated rock candy. If you've ever made or seen rock candy, what you have to start with is a supersaturated solution of sugar in water. And then what you do is you add more than you need. And here's the trick. All these are temperature related. So what you'll do is you'll raise the temperature, more sugar will dissolve, and then you'll slowly bring the temperature down. And if you're making rock candy, you can put those little wooden sticks in there. And if you've ever seen rock candy, it's jagged all over the place. That's the crystals as they're forming, they form those structures. So supersaturated is actually kind of hard because things want to shock and come out of solution. They want to stay at saturated or less. We're in the South, so those of you who have learned to make sweet tea, do you add the sugar once you've made the tea to the level strength that you want it to after you've added the cool water to it, or do you add the sugar while it's hot? Well, everybody knows you add the sugar while it's hot because it will dissolve more easily. Once it's cold, it won't hold as much sugar, so if you're brought unsweetened cold tea, you can sit there and stir all day long. And until the temperature comes up, that sugar is not dissolving, so your unsweetened tea will stay unsweetened. So when we talk about solutions generically, we're going to talk about these values. Okay, here is a slide that shows you that solubility is a function, again, of temperature. So what you've done here is this is a supersaturated solution, and you have shocked it. And there are a variety of ways to shock it. You can hit the container. In this case, they used a seed crystal, and it's called a seed crystal because then everything will form on top of that. And notice that we start down here and up here as the crystal falls through, and then with time it goes through the whole thing, and it will continue to solidify until it has reached the saturation level. Now you can go to Hobby Lobby, any craft store, a variety of places. I did not look at Dollar Tree, but you can often find how to grow crystals, and they give you a packet of water. You're supposed to mix it up, and then it grows up. And a lot of times they'll give you a shape, and what happens is the water goes up and evaporates off. It leaves the crystals after it, so it looks really cool. It's not really in any way, shape, or a full crystal, but it's cool looking anyway. All right, so that brings us to another couple terms associated with solutions, which is solvation, and that's when the solvent particles, because remember, we are homogeneous, so we are dealing at a atomic molecular level, surround the solute particles. Now, if the solvent is water, we call it hydration. So all hydration is solvation, but all solvation is not hydration. So what you'll see here is, notice that you have the water molecules surrounding, this is the sodium ion, and this is the chloride ion. So we call this solvation, and it can be any solvent, any solute, etc. And hydration is when the solvent is water, which is easy to remember because if you're hydrated, you have lots of water. Okay, so the last thing I want you to look at is some other terms. These are kind of the last ones. In the next section, we're going to go into how solutions form. We have miscible, immiscible, and partially miscible. So this is an interesting word, but what it means is miscible is it will mix in all proportions. So one of the things we find is ethanol, which is CH3COOH, that's ethanol, is miscible with water. So it doesn't matter whether you mix a little ethanol with water or a lot of ethanol with water. It will mix in all proportions. Immiscible will not mix. And over here, what we've got here is carbon tetrachloride and water. And the brown coloring here is caused by iodide, which actually you start with it in the water. And the iodide prefers the carbon tetrachloride. So over time, it's going to move down into the carbon tetrachloride. And I'm going to try to see if I can make a video of this because I think it's really cool. And then partially miscible means it will mix in small amounts. Now, this is usually easier to see if you have a test tube. What you'll have is, instead of having a defined layer for immiscible, for partially miscible, what you'll have is you'll have kind of like a cloudy layer. And it's all cloudy in there. Sometimes if you make oil and vinegar dressing and you add other ingredients like lemon juice or different, like an oil, like a cayenne pepper or something oil, then depending upon what's in it, it may partially mix. So you get this kind of cloudy layer. And that will show you that it's partially miscible.